Hello, this is Geometry Lesson 7. In this, I will discuss about the area of triangles. Now, this I have drawn an equilateral triangle. You can see that all the sides are of a centimeter and a centimeter. Now, first I will draw the centers of triangle within this triangle. Then I will relate them with the area of a triangle. Now, first let me draw the orthocenter. What was orthocenter? That was a point where perpendicular from the vertices to the opposite sides meet. Let me draw the perpendicular. This is perpendicular number 1. This is perpendicular number 2. And this is perpendicular number 3. Third perpendicular. This I have drawn 3 perpendicular. At this point is D, this point is E, and this point is F. This point is, let's say, O. So I can say that O is the orthocenter. O is the orthocenter. And your AD, BE and CF, they are altitude. Altitude, you can say that perpendicular. These are the altitude. Now, this O is the orthocenter in equilateral triangle. Now, I can also prove that this triangle ABD is congruent to triangle ACD. ABD is congruent to triangle ACD. So why is this congruent? This is congruent by RHS. RHS congruency. You can see that both our triangles are right angle triangle. So 90 degrees equals to 90 degrees there in both the triangles. AB is equals to AC. Hypotenuse is equals, so right angle is there, hypotenuse is equals. What about common side? AD is the common side which is there in both the triangles. So these two triangles are congruent by RHS, and we know that once the triangles are congruent, so all corresponding sides as well as all corresponding angles are equal. So can I say that this complete angle A, we know that in equilateral triangle all angles are of 60 degree each. So this angle will be 30 degree and 30 degree because these two triangles are congruent. In congruent triangles, the corresponding angles are equal. So this will be 30 degree because complete A angle is 60 degree, and that will be divided into two parts, and both parts will be equal because the triangles are congruent and these are the corresponding angles, so they will be equal. Same way we can prove that this angle is 30, this angle is 30 because angle C is 60 degree because triangle is equilateral. Same way this angle is 30, this angle is also 30. Now, can I say that as the triangles ABD is congruent to triangle ACD, we have proven this 30 angles. This side will be equals to this side because these two triangles are congruent, ABD as well as ACD. So their corresponding side BD and CD will also be equal. Now, can I say that AD act as a median? Same way we can prove this. These two sides are also equal. These two sides are also equal. Now, can I say that O is the centroid? O is the centroid as AD, BE and CF not only they are altitude, they are median also. Because what is the property of median? Median divide the third side into two equal parts. Your AD divides the BC into two equal parts. So AD is also the median. Same way BE and CF. And O is the centroid. Can I say that AD, BE, CF are the altitude as well as median, as well as perpendicular bisectors? Because AD is perpendicular to BC as well as AD bisects BC. So can I say that AD is also perpendicular bisector as well as AD is an angle bisector? Same is true for BE and CF. So can I say that in an equilateral triangle, altitude is act as a median as well as perpendicular bisector as well as angle bisector, and the O, that orthocenter, is also the centroid, also the circumcenter, because where perpendicular bisector meet, also the equals to incenter. So can I say that in an equilateral triangle, all centers of triangle lie at one particular point, and this is only true for equilateral triangle. In only in equilateral triangle, all centers lies at same point. All centers, that is orthocenter, centroid, circumcenter, incenter, all centers lies at the same point, and that is only true for equilateral triangle. In other triangles they lie at different points. As O is the orthocenter, we can always draw the circle that will pass through the triangle. So circumcircle I am making with this center O. We can always draw the circumcircle that will touch all the vertices. This is a circumcircle, and OA, OB and OC are the circumradius. So your OA, OB and OC are the circumradius, that is capital R. Same way O is the in center, also like the same point in equilateral triangle, you can always draw the in circle. This O is in center, you can always draw the in circle. This is the in circle. So can I say that OF, OD, OE, that will be in radius, that is small r. So in radius and circumradius. Now what will be the relation in between these two radius? Now can I say that O is the centroid? O is also the centroid. Now centroid divide the median in the ratio 2:1. AD is the median. So centroid will divide this AD median in the ratio 2:1. So can I say that OA is to OD, this ratio OA is to OD, this ratio must be 2:1, because O is the centroid, it divides the median in the ratio 2:1. This part AO will be twice, this part OD will be 1, because I discussed that centroid divide the median in the ratio 2:1. So OA is to OD, this ratio is 2:1. So can I say that, I'm just converting here, OA is to OD, this ratio is 2:1. Can I say that OA is the circumradius, OD is the inradius, this is equals to 2:1. Again, a very important concept, that only in equilateral triangle the circumradius and inradius are in the ratio 2:1. It means that circumradius is double that of inradius, only in equilateral triangle. Now I will discuss with you the area of triangle. The first and most important method to calculate the area of triangle is half into base into height. Area, this is first method, how to calculate the area. Area is half into base into height. Half base of the equilateral triangle, you can say that the base is A, because the length I have taken A. What about the height of an equilateral triangle? Height is AD. Height of equilateral triangle AD. How can you calculate? You can apply the Pythagoras theorem, AD square plus CD square, and this will be equals to AC square. So AD square, CD square is, this is A by 2, because complete length is AD, A centimeter, this will be A by 2, this is equals to A square. So you will get AD square is equals to A square minus A square by 4, that is 3A square by 4. So AD would be root 3A by 2. Root 3 by 2A. Very important, the height of an equilateral triangle, you can straight away understand that height of an equilateral triangle is root 3 by 2A. Root 3 by 2A. So what you will get? You will get area is equals to root 3 by 4A square. Very important, you must straight away remember that area of an equilateral triangle is root 3 by 4A square. And the height of an equilateral triangle is root 3 by 2A, where A is the length of the side of an equilateral triangle. Next formula to calculate the area is Heron's formula, which says that if ABC are the length of the side of a triangle, then area can be given as S into S minus A into S minus B into S minus C whole square root, where S is the semi-parameter, that is A plus B plus C by 2. In our case, the equilateral triangle that I made, you can say that semi-parameter will be what? Semi-parameter will be A plus A plus A by 2, as all the three sides are of same length. So semi perimeter will be 3a by 2. Put the values of S and A, B, C. All the sides are A. So you will get S into S minus A, S minus A, S minus A. As in our case, the whole side are of A centimeter. So you will get again area as same, that is root 3 by 4. Again with this method you will get the area as, after solving, putting the value of S, you will get area as root 3 by 4 A square. That is the area of equilateral triangle. So that was the second concept to calculate the area. First was half into base into height. Second is Heron's formula. Third method is also very important. It says that area can also be calculated. Area A can be also calculated as half into any two adjacent sides. I am taking, let's say, AB into AC. Any two adjacent side and the sine of angle between them. Sine of angle between side AB and AC. Between side AB and AC you can see that there is angle A. So area can be calculated half of any two adjacent side and an included angle sine A. So in our case this will be equals to half. AB is A, AC is also A, sine 60 degree, because angle A is 60 degree. Again this you will get half into A square. Sine 60 is root 3 by 2. Again the answer is same, root 3 by 4 A square. That is the area of equilateral triangle. You can take other two side also. Any two side you can take with an included angle. You can take BA, half into area of the triangle could be half into BA into BC. BA into BC. Now BA and BC, you can see that what is the included angle between them is angle B, sine B. Again answer will be same, root 3 by 4 A square. Fourth concept to calculate the area is, suppose that this is a triangle is given to you, ABC, with sides as A, B and C. You can calculate the area as ABC upon 4R, where R is the circumradius. R is the circumradius. So in the R triangle, that the triangle we have made, the sides are A into A into A, ABC are all the same sides of length A centimeter. 4 times, what is the circumradius? Now how to calculate the circumradius? There is a relation between circumradius and inradius. Can I say that AO is to OD, this ratio is 2:1. And we know that AO plus OD is equals to AD. Let's say this is 2x, this is x, this will be 3x. So can I say that AO, that is circumradius, AO is the circumradius, this is 2/3 of AD, that is 2/3 of height, because 2x is 2/3 of 3x. So can I say that circumradius is 2/3 of height in an equilateral triangle. And in radius OD, that is small r, that is 1/3 of height only in equilateral triangle. So 2/3 of AD, we know that height of an equilateral triangle is root 3 by 2A. I just calculated few slides back. Height of an equilateral triangle is root 3 by 2A. So this and this cancel. Can I say this is equals to A by root 3. A by root 3. Solving this, put the value here. You will get this. Can I say this? I am just putting A by root 3. Again your answer would be root 3 by 4 A square. That is the area of equilateral triangle. Solving this complete, you will get area as root 3 by 4 A square. So very important, area also equals to ABC upon 4 times the circumradius. This formula are rarely used, but still we must know how to calculate the area when circumradius is given to you. The last fifth formula to calculate the area is A is equals to R into S, where R is the inradius, S is the semi-perimeter. So inradius, can I say that this OD into semi-perimeter is, in this case, A plus A plus A by 2. What is OD? OD is 1/3 of height of an equilateral triangle. 1/3 of height, that is 1/3 of root 3 by 2 into A into 3A by 2. So can I say 3 and 3 will be get cancelled, or you will get root 3 by 4 a square. Again the same area you will get of equilateral triangle. So area is equal to small r into s, where small r is the in radius. Again, as in the case of circumradius, this formula is not much used, but still we must know that area is equal to small r into s. Now finally summarizing the 5 types of area. First is area is equals to, you can say that, I'm just calculating this, area is equals to half into base into height. You can calculate the area as Heron's formula, s into s minus a into s minus b into s, this is s minus b, s minus c upon whole square root, where a, b, c, where s is the semi parameter, that is a plus b plus c by, do this second formula to calculate the area. Third was half into any two side. Let's say I'm taking AB into AC and the sine of angle between them, sine A. Fourth could be very important, area is equals to ABC upon 4R, where R is the circumradius, ABC are the sides of a triangle. And the fifth one was area is equals to small r into s, where small r is the inradius, s is the semi parameter. These three formula 1, 2, 3 are mostly used, especially the first formula is very important. Second, less used than first. Third, less used than second. And fourth and fifth are rarely used to calculate the area of triangle. So that was all about lesson 7, area of triangles. Thank you.